Hello students, how are you all? I hope you all are doing great. Welcome to Glecta. I'm your chemistry faculty. So today the topic for you all that I've chosen is the periodicity and properties of the periodic table. How do the different groups and the periods vary in order of the different properties? How does the different properties vary in various groups and periods of the periodic table? Today we'll be discussing all of that. So the learning objectives for the day would be a detailed study about the periodic properties and the variation in the periods and groups, then what are metalloids, D block elements and the properties, how metals and non-metals differ from each other, then the electronic structure and position of metals and non-metals in the periodic table. So there are certain terms which will be used frequently in this lecture. What are those? Firstly, elements. What is an element? Elements constitute the simplest chemical substances in which all the atoms are exactly the same. An element is a substance that cannot be broken down into a simpler format. That means they can be distinguished by a unique atomic number. So you see here, elements with the similar physical and chemical properties have the same atomic number, and an atomic number is unique for each of the different element. That means it is a unique for a particular element, and it is the smallest chemical substance which cannot be distinguished or broken down into any other simpler form. So in the last video we had talked about the historical development of the periodic table, correct? And today, now in this particular video, we'll be discussing about how the different properties vary in the order of when they are arranged in different groups and periods. The elements are organized by their atomic number in the periodic table, which highlights element with similar properties. That means they are organized in the periodic table. We know that in the modern periodic table, elements are arranged in the order of their atomic number, and these atomic number highlights elements with similar chemical properties. Now this is the modern periodic table. You can see here the first two groups are the S block elements, then the third to 8th group forms the P block elements. In the middle of the two we have the D block elements or the transition elements, and at the bottom of the periodic table, that is below the main periodic table, comes the lanthanides and actinides series, which forms the F block elements. Now in this periodic table it is arranged in different groups and periods. Now the horizontal rows of the periodic table are called the periods, and there are 7 periods in all, whereas the vertical columns of the periodic table are called the groups, and there are 18 groups in total. So that is the main periodic table. Now I have a small video for you all, and I want you all to just have a look at this particular video. Now what do you see from this particular video? There are different metals you see which are being beaten down into thin sheets and thin wires. This property of metal is known as malleability and ductility. So what are metals? And first of all, metals are shiny, lustrous elements, right? So metals in the pure state have a shiny surface. This property is called its metallic luster. Then when we talk about the other property, you will find that some of the metals can be beaten down into thin sheets. This property of the metals to be broken down into thin sheets is called malleability. Do you know that the gold and silver are the most malleable metals? As you know that gold and silver are widely used in our day-to-day lives to form many of the articles that we use, and that is why they are quite malleable. That means they can be broken down into thin sheets. Then the other property of the metal is the property of ductility, which enables the metals to be drawn into thin wires. Now, gold is again the most ductile element as well. You will be surprised to know that a wire of about 2 kilometer length can be drawn from 1 gram of gold. So, you see here 1 gram of gold can produce a wire of about 2 kilometers length. How interesting it is, right? So, metals have a property of metallic luster, they are malleable and they are ductile as well. Also, metals are good conductors of heat and electricity, and they also have very high boiling point, and they also have very high melting point. Lead and mercury are comparatively poor conductors of heat. So, there are two metals which are exceptional, that means they have poor conduction of heat, and those are lead and mercury. Whereas the best conductors of heat and electricity are silver and copper. That means silver and copper can be utilized in various ways when thermal conduction is concerned about. So, because they are very high or good conductors of heat. So, you see here when you heat a metal rod or a glass rod, which will burn first, which will take the fire first, a glass rod or a metal rod? A metal rod, because they are very high or good conductors of heat and electricity. So, now talking about the non-metals. The non-metals are generally carbon, sulfur, iodine, oxygen, hydrogen, etc. These are either solids or gases. So, non-metals are generally solids or gases, whereas metals are normally, in general cases, they are all solids. Whereas in case of non-metals, there is one exception, which is iodine, which is bromine, which is a liquid at room temperature. Carbon is a non-metal that can exist in various allotropic forms. Now, carbon is again a non-metal which has different allotropic forms, which is diamond, graphite and Buckminster fullerene. So, you see here carbon has an allotrope which is diamond, and it is the hardest known substance which is known. And graphite is again a form of carbon which is a very good conductor of electricity. So, carbon is the hardest natural substance known, and it has a very high melting and boiling point, whereas graphite, its other allotropic form, is a good conductor of electricity. A non-metal is typically dull and a poor conductor of electricity and heat. Now, just opposite to the property of metal, a non-metal is dull, whereas metals we have seen that they are lustrous and they are poor conductor of electricity and heat as well, whereas metals are good conductors of heat and electricity. But there is again an exception to this, which is graphite, which is a good conductor of electricity and heat. When we talk about the solid non-metals, they are also very brittle. That means they cannot be broken down. They do not have the property of malleability and ductility. That is, they cannot be broken down into thin sheets or thin wires, and they are very, very brittle. These are all the non-metals in the periodic table, like carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, helium, neon, argon. These all are either solids or gases and are known as non-metals. The next comes the metalloids or the D block elements, or we also call them the transition elements. Those are boron, silicon, germanium, arsenic, antimony, tellurium or yttrium. These all are the metalloids. The elements which have the properties intermediate between those of the metals and non-metals. So you see those elements which have the intermediate properties, that is in between the metals and non-metals, are called the metalloids. The D block elements are these elements from group 3 to group 12, which forms the periodic table, middle of the periodic table. These are known as the inner transition elements or the D block elements. Now these D block elements have certain properties as well. This element, which is the argentum, the country Argentina is named after the element silver, which is argentum in Latin. You see here this element argentum. You see here the country Argentina is named after the element silver, which is in Latin we call it as argentum. Now there are certain properties of the transition elements which are as follows. First, they form stable complexes, then they have very high melting and boiling point, they contain large charge to radius ratio, form compounds which are often paramagnetic, are hard and possess high densities, form compounds with profound catalytic activity, that is they are very efficient catalysts due to their high charge to radius ratio. And they show variable oxidation states as well. They form colored ions and compounds, then these are used as catalysts in various chemical reactions. You see, these are transition elements, and each of the transition element form a different colored compound due to their variable oxidation state. So manganese shows a color of pink, chromium 3+ has a color of green, whereas chromium 6, that is chromate ion, has a color yellow, nickel is again green, dichromate is orange, permanganate, that is manganese, is purple, iron 3+ shows a green color, whereas iron 2+ shows a green color, whereas iron 3+ will give you brown color, copper ion Cu2+ would give blue color compound, and the cobalt Cu2+ would give the pink color compound. So transition elements have the properties of variable oxidation state, and due to this variable oxidation state they form different colored compounds. So how do metals and non-metals react with each other, and what are the periodicity in the properties of different metals and non-metals? You see that they have different conduction when we talk about heat and electricity, and they have different properties as well, like when we talk about metallic luster, when we talk about malleability and ductility, metals and non-metals differ. But how are different properties that we'll be talking about differ when we talk about various metals and non-metals? So first comes the oxidation state. The oxidation state of an atom is defined as the number of electrons gained or lost by it. That is, it is the most fundamental property of the element and are studied with the help of its electronic configuration. For example, if we talk about the S and P block elements, what will happen? In the case of S and P block elements, it is generally calculated as 8 minus the number of valence electrons or the number of valence electrons. That means for the S block elements, that is if we talk about lithium, which has the atomic number of 3, the atomic configuration becomes 2 and 1. So the number of valence electron becomes its oxidation state. So lithium has an atomic oxidation state of +1. Whereas when we talk about the P block elements, it is equal to the 8 minus the number of valence electrons. For example, if we talk about oxygen, which has an atomic number of 16, atomic number of 8. Now, how can this be arranged? It is 2 and 6. So, it would be equal to, the oxidation state would be equal to 8 minus the number of valence electrons, which is equal to 2. So, oxygen shows an oxidation state of 2. Now, when we talk about the charge, that is, if you talk about the oxidation state varies on compound to compound. For example, if you talk about Na2O and F2O, the oxidation state of oxygen in both the compounds is different. For example, you see here, oxygen being more electronegative than sodium will attract the shared pair of electron, and it will show an oxidation state of -2, and sodium will have the oxidation state of +1. Whereas in case of fluorine, fluorine would show, since fluorine would be more electronegative than oxygen, it would show an oxidation state of -1, and oxygen would show a oxidation state of +2. So this oxidation state varies from compound to compound. So down the group, when we talk about the oxidation state, there occurs no change in the number of valence electrons. Thus, down the group, all the elements of a group shows the same oxidation state. Whereas when we talk about moving from left to right in a period, what will happen? The number of valence electrons increases and changes between 1 to 8. Whereas the valency or the oxidation state, when first combined with hydrogen or oxygen, it initially increases from 1 to 4. It will go from 1 to 4 first across when we move from left to right in a period, and after that it reduces to 0. That means 8 minus the number of valence electrons, and it will start to decrease and reduce to 0. Then the second, which is the atomic radius. When we talk about the atomic radius, it is the atomic radius of an element is a measure of the size of its atoms. That means it represents the mean distance from the nucleus to the boundary of the surrounding cloud of electron. So when you see, as the atomic number increases along each row of the periodic table, when you go from left to right, the atomic number increases. As the atomic number would increase, the additional electron, the number of valence electrons would again increase, and the additional electron would go into the outermost shell, causing the atomic radius to decrease due to the increase in the nuclear charge or the repulsion between the different electrons. So when you move from left to right, the atomic number increases, the electron in the outermost shell would go into the additional electron would go into the outermost shell, causing the repulsion between different electrons, and as a result the effective nuclear charge would increase, and this increase in the nuclear charge would decrease the size. So atomic radius would decrease when you go from left to right in a periodic table. Now, while moving down the group, when we talk about down the group, the atomic radius then would increase. And why is that? It would be because of the presence of an additional principal energy level which are further away from the nucleus. When you go down, there would be an additional energy level or energy shell which will be added, and that energy level would be farther away from the nucleus, as a result of which the nuclear charge, that is the attraction between the outermost shell and the nucleus, would now decrease, and due to this decrease in the nuclear charge, the atomic radii would now increase. Now when we talk about the electronegativity, electronegativity would increase as we move from left to right across a period. Why is that? The electronegativity would increase, and why is that? Now because since the atomic radius would decrease in a period, the attraction between the valence electron and the nucleus would increase. Hence the tendency to attract the shared pair of electron would increase, and as a result the electronegativity would increase. As we know that electronegativity is the measure of the attraction of the electron by the nucleus. So as the size would decrease, the attraction between the nucleus and the valence electron would now increase, and because of that increase in the attraction, which is the electronegativity, it will again increase. When we talk about down the group, what will happen? Down the group, the electronegativity would now decrease, because down the group the atomic radius decreases, and when the atomic radius would decrease, the size of the down the group the atomic radius increases, and when the size of the atom, that is the atomic radius, increases, the nuclear attractive force, that is the attraction between the nucleus and the valence electron, would decrease, and hence electronegativity would decrease down the group. Then we come to the other term, which is electron gain enthalpy. It is defined as the enthalpy change which is associated when an isolated gaseous atom combines with another electron, that is, it gains an electron to form its corresponding anion. That means if you have a isolated gaseous atom and it gains an electron to produce an anion in the gaseous state, then the energy change which is associated with this particular reaction, that is with the gaining of an electron, is known as the electron gain enthalpy. Now, how does it vary across a period and down the group? Now, when we go from left to right, the atomic size, you know that the size of the atom decreases, and that means the effective nuclear charge, that is the attraction between the nucleus and the valence electron, would increase. Thus, the force of attraction between the nucleus and the added electron will be more, hence it will be able to gain the electron more easily, and the electron gain enthalpy would be now more negative. The electron gain enthalpy would become more negative. Now, when we talk about down the group, what will happen? Down the group, the electron gain enthalpy would become less negative. And why is that? Because as we go down, the atomic size and the nuclear charge increases, because of the increase in the atomic size, the nuclear charge would decrease, but the effect of atomic size is more prominent than that of the nuclear charge. Hence, the force of attraction between the nucleus and the added electron would decrease, and thus the enthalpy becomes less negative. Then the next, which is the main thing, is the diagonal relationship. The diagonal relationship is said to exist between certain elements in the periodic table. These elements are placed diagonally adjacent in the second and third row of the periodic table, that is, among the first 20 elements. The diagonal elements usually show similar properties in their generally show similarity in their properties, which is exhibited on moving from left to right and decrease down the group in the periodic table. And it is more prominent among the lighter members, that is, between the pairs that are shown in this particular image. You can see that there is a diagonal relationship that exists between lithium and magnesium, beryllium and aluminum, boron and silicon, and carbon and phosphorus. That is, these elements of the second and third period show similarities in their chemical and physical properties, and the relationship between these elements is termed as the diagonal relationship. That was all about the periodicity and its properties, and how does these properties vary across a period and down the group. Now, discussing some questions. The elements of the second period of the periodic table are given below. These are the elements of the second period. Give reasons to explain why atomic radii decreases from lithium to fluorine. As we all know that when we move across the period, the additional electron would go into the similar shell, that is the valence shell, and as a result of which the effective nuclear charge between the electrons would increase as a result of the repulsion, and therefore the size would now decrease. So that is why atomic radius decreases from lithium to fluorine. Now identify the most metallic and the non-metallic element. You know that the metals are generally solids, whereas non-metals are generally solids and gases, and they are placed in the right hand side of the periodic table, whereas the metals are placed in the left hand side of the periodic table. So lithium would be the most metallic and fluorine would be the most non-metallic. Lithium would be the metallic element and the non-metallic element would be the fluorine. Now element X has a melting point of 1453 degrees Celsius, element Y has a melting point of 1083 degrees Celsius, and element Z has a melting point of 63.4 degrees Celsius. Which element is placed in group 1, X, Y or Z? Now you know that group 1 are all the metals, and 1453, 1083 and 63.4. So metals have a very low melting point. That means element Z would be placed in the group 1 of the periodic table. Which of these elements is a catalyst for the production of ammonia? Iodine, iron and sodium. From the properties of the transition elements, we know that they form a very good catalyst, right? So among these options, iron is a transition element, that is a d block element, and it can be used efficiently as a catalyst for the production of ammonia. Which property is typical of a transition element? They form ions with different charges, they are not strong, or they are in the gaseous state at room temperature. The only property which is typical of the transition elements, that is shown only by the transition elements and not by the others, is the capability of forming ions with different charges, right, that we have studied. They show variable oxidation state, that means they form ions with different charges. For example, iron can form a compound with +2 oxidation state and also +3 oxidation states. So they can form ions with different charges. As you move from top to bottom on the periodic table, why does electronegativity decrease? From top to bottom, electronegativity decreases, correct? And why do that happen? Because the outermost electron gets farther and farther away from the nucleus, and as a result, the attraction between the nucleus and the bonding electron would now decrease. So this would be the correct option, and not because the outermost electron get closer and closer to the atom's nucleus, the attraction between the nucleus and the bonding electron decreases. No, because the outermost electron get farther and farther away from the atoms, the attraction between the nucleus and the bonding electron increase. No, because the outermost electron get closer and closer to the atom's nucleus, the attraction between the nucleus and the bonding electron increases. No, these all are wrong options. Only the correct option is the first one, because the outermost electrons, when we move down the group, as the size would increase, the outermost electrons get farther and farther away from the nucleus, and as a result, the attraction between the nucleus and the bonding electron decrease, because of which the electronegativity would also decrease. Which of these properties is typical of transition elements but not group 1 elements? They conduct electricity, they have high melting point, or they are shiny when freshly cut. Both group 1 elements and transition elements can conduct electricity. They are also shiny when freshly cut, but the group 1 elements have a low melting point when you compare it to the transition elements. So that is why we say that this property is only typical of the transition elements. Now platinum and gold are used extensively in the production of wedding rings, right? They both have specific properties which make them ideal for this use. Which of these properties is it? These metals are extremely tough and hard? No. These metals have low densities? No. These metals do not react with water? Yes, these metals do not react with water. These metals have low melting points? No. These metals do not react with air? Yes, correct. So the properties of gold and platinum, that is they do not react with water and air, make them helpful in the production of wedding rings. So that is why these two options are correct for platinum and gold, that is they do not react with air and they do not react with water, and that is why they could be used extensively in the production of wedding rings. So that's all for this particular video. I hope the difference between the metals, non-metals, the transition elements, that is the metalloids, is clear, and how do different properties, that is oxidation state, electronegativity, atomic radii, electron gain enthalpy, is all clear to you, along with the diagonal relationship between the elements of period 2 and period 3. That all is clear to you. And also, if you have any doubts or any questions regarding this particular video, you can ask them in the comment section. They would be more than welcome, and we'll be happy to answer all of that. So I'll be seeing you in the next video with a new topic for you all. Till then, take care of yourselves. Thank you and bye-bye.